So good morning. Thank you, Daniel, and thank you for joining my presentation. And also thank you for the LoRaWAN to give me this opportunity. So I'm Masato Yamagi from the Yokogawa Electric Corporation, and I'm in charge of the product manager of the industrial IoT solutions. Okay. So Yokogawa has been offering the LoRaWAN-based IoT solution for 5 years. So today, I'd like to present the industrial equipment health monitoring and energy conservation in plant. So, and this week, we have just released our new solution regarding the energy monitoring solution using the LoRaWAN. I will add this topic in my presentation. Okay. So the purpose of the plant activity is securing a stable profit and to be a sustainable business growth. So currently, production operation is already efficient and optimized. On the other hand, so a lot of the plant are operating over 40 and 50 years, and aging equipment makes a trouble frequently. So higher efficiency and high quality equipment management are required. So, but it takes a cost. I think the IoT is a key to solve the issues. The biggest operation loss in the plant is plant shutdown by equipment failure, which may cause a production halt and operation losses. So loss is from the 10 to several hundred thousand US dollars per hour. So in general, less than 30% of the total asset in the plant are constantly monitored, and the others one not monitored or monitored by operator rounds. A customer said, so if the equipment status monitored well, about 70% of the trouble can be prevented. So the critical issues for the equipment monitoring can be categorized into the following 3 points: scope, quality, and efficiency. So the over 70% of the equipment are not constantly monitored because of the lack of the manpower, or online monitoring system is too expensive. For quality, the oversight of the anomalous signs could be happen because of the long-term interval, such as every half year and every 1 year, and so on, and human error and the dependence of the worker skills. For efficiency, the current operator rounds are not efficient because most equipment works fine. The operator have to spend their time to check even such a healthy equipment. So there are some challenges for the equipment monitoring. For the scope expansion is required. All equipment related to the plant operation must be monitored with cost-effective way. The quality early detection of anomaly sign to prevent the overlook is required. The challenges are the shorter interval monitoring and free from the worker ability, and online collaboration with subject matter expert. For efficiency, the challenge are the reduction of the working hours and cost by replacing the operator rounds. And online data sharing is also necessary. To overcome these challenges, so we are required to change to the customer's current maintenance way by IoT. So to solve the issues, the LoRaWAN-based monitoring is the best. Here are the key success factors: wide coverage. So the coverage area is thousands of the times of the Wi-Fi and the Bluetooth. So no wireless coverage consideration is required. The scalable network. So the huge number of the sensors the sensor data are gathered to the LoRaWAN scalable network. The both two is essentially important for the IoT system. And also the low cost installation and means zero cabling cost and no repeater, as you know, and radio penetration, so excellent communication transparency indoor or outdoor through the barriers. The easy startup, the LoRaWAN can be set up without complex configuration. Okay. So as I explained, so most of the equipment are working fine. So it is not a good way to check one by one by the expert. Our solution is totally same with medical care. So I think you don't go to the medical specialist from the beginning. So first, you may have a regular medical checkups, and if there is something wrong, you will go to the you will have a detailed diagnosis by each medical expert. So diagnosis in the plant is same. So make a triage by simple diagnosis, like a medical checkup by LoRaWAN sensors. And then make a detailed diagnosis only for the high risk equipment by expert. This is the key to separate simple diagnosis and detailed diagnosis. So this two-step approach can be reduced unnecessary inspections and allow to the expert to focus only for the high-risk equipment. We think the LoRaWAN solution is the best for simple diagnosis to be efficient maintenance work for the huge number of equipment. Okay. So Yokogawa has released a LoRaWAN-based solution. It is called the Sushi sensor. The Sushi sensor offers a new way to realize the digital transformation to the maintenance field. So after deployment of Sushi sensor, anomaly signs are automatically detected, and experts can focus on the high-risk equipment. So online data collection and monitoring, and easy to compare the past trend or other equipment data without human skills, and safer monitoring operation. That is we can achieve. So from this slide, I'd like to explain some use cases. First one is oil well head monitoring for the upstream oil field. Okay. So oil and gas mining area is, as you know, very, very huge. So LoRaWAN long distance feature is very welcomed. So this application is actually the oil well pressure monitoring. The wellhead spread for the several 10 kilometers, like this. So there are thousands of equipment that cannot be fully covered by operator rounds. So sensors are introduced to monitor the health of the drilling rig and the surrounding equipment. The customer's benefit is sensor reduces both customers' capex and opex. For the capex side, the customer can achieve the lowest installation cost due to the excellent environmental resistance, explosion proof, and long distance communication. For the OPEX side, so this is ROI simulation when the sensor deploys these applications. So we estimated customer pays $3,000 to inspect 6,000 wells for each operator round. So online monitoring can eliminate such a cost. We estimated the operator round cost for each well is $5 per well. So if the customer want to have every 1 hour data by operator round, the yearly cost is about $44,000. So customer can recover this LoRaWAN solution investment in a very, very short period. Second one is air ventilator monitoring for the subways company. So the subway company has a lot of the ventilator to circulate the fresh air from its station and the tunnels. The customer's concerns are the unexpected shutdown makes a huge maintenance and mitigation cost. And insufficient frequency inspection did the overlook of the failure trend. Okay. And inspection quality is depending on the worker skill, and it is hard to pass down to the next generation. The customer's challenges are the changing from the operator LAN to the operator online monitoring. So shifting from the time-based maintenance to the condition-based maintenance by detecting a sign of the anomaly. The customer has decided to install our vibration sensor to ventilator located at each station. So the one key success factor is radio reachability because the ventilators are located in the basement. It is hard to communicate in the thick concrete walls and iron doors, but LoRaWAN could do it. After the deployment of the sensor, the customer can know the anomaly earlier and can prioritize the maintenance works. The customer can make a long-term and mid-term maintenance plan and can consider the maintenance budget plan before the equipment fails. Okay, so this is my last topic, but the latest one. So this week, we have released the energy loss management solution as a new family of the Sushi sensor. I will explain the purpose and what we provide. So this is the background information. So currently, the efficient energy utilization is one of the important discussion points in the world. So reduction of the fuel usage to reduce the decarbonized society, and effective use of the energy, especially the heat. Okay. So not only the oil and gas and chemical plant, but the steam is commonly used as a heat source like air conditioning. So because it is very efficient and easy controlled. So steam is distributed from the boiler to any location it requires. However, currently, steam is not managed properly, resulting in a large energy loss because the steam equipment failure does not lead a plant shutdown directly. But recently, the steam management is attracting more attraction due to the recent sharp rise in the energy procurement prices and carbon pricing and SDGs and ESG perspective. The waste of the energy does not directly affect the plant operation, but it has a very large impact for the sustainable plant operation. Okay. So steam trap is a very important equipment to consider the energy loss in the heat distribution. So it is a separator between the steam and the condensed water. So if the condensed water in the steam piping, steam is cooled and it makes the worse heat distribution efficiency. So to keep the steam volume and its temperature under the worse situation, so more fuel is required. But in practical, steam trap fails frequently because it is mechanical devices. So customer understands the importance of the steam trap management, but no good solution had not been existed. Because the number of the steam trap is huge and it spreads all over the plant. so it was difficult to monitor the status with cost-effective way. Once failure happens, it caused more than the 300 tons of steam loss and over the $1 million financial loss yearly. The solution is to monitor the status of the steam trap by using the steam trap monitoring devices. So LoRaWAN based steam trap monitoring can be introduced for existing steam traps located all over the plant easily. No wiring works, no expensive infrastructure is required. By monitoring the steam trap monitor online, so customer can find the failed steam trap easily and can take a replacement action quickly. So it can stop the unnecessary energy loss and can directly contribute to the SDGs and ESG activities. The conclusion summary. So LoRaWAN based Sushi sensor realize higher efficiency and high quality of the plant operation with long distance communication and flexible installation features. In equipment monitoring, so Sushi sensor can prevent unplanned shutdown and can avoid huge production and operation losses. So in addition to this, so regarding the energy conservation, so Sushi sensor can contribute to reduce the energy loss and carbon's greenhouse gas by notifying the steam loss in early stage. So Yokogawa has a table at the marketplace behind you, so you can find a new solution at there. Please visit our site. That's all from me. Thank you very much for your kind attention.